CK. I've complained a couple of times in the last few months about not having a good multiple out here in the lab, so I bought a buffered multiple from Synthrotek. I've done one other of their units. I did, I forget which one it was, you can look it up on the channel, and I liked it, so we'll give this one a try and see how much fun it is. Hope you enjoy the video. So here it is, MST 07 buffered multiple from Synthrotek, who are out of Oregon, I believe. So let's open this up. See what we got. First we have a bill of materials, which, hooray, the color is okay on this. It's still not great. It'd still be hard to tell. No, it's going to be real hard to tell color bands on here, particularly, well, these are just 1K and 10 and 100K, so color bands are all the same color, so it doesn't much matter. Bunch of jacks, pin headers. We'll see as we get in there, but that's enough to build the kit with. You don't even need a build guide. So thanks for purchasing. Kit put together May 17th of 22, which is just last month. And they're saying, need any help, just let us know, which I appreciate. I like it when companies are there to stand by you. Let's get out the circuit boards and the front panel first. So here's the front panel, and pretty much what you'd expect. 4 ins and 4 outs for each in, which is a lot for a 4U wide unit. Oh, by the way, this is a composite, not aluminum, front panel. Neither good nor bad, just interesting. Now let's look at the circuit boards. Which, as you can tell, is going to be mostly jacks. Jack, 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 jack. Lots of jacks. And the pin headers down the middle to hold it all together. And I assume these holes are for spacers to keep the boards separated. And here is the electronics board. And as you can see, there's a whole bunch of what I don't really like all that much. These are all stand-up resistors. I'm not a big fan of stand-ups. I know in this case, this is really keeping it into 4U. So that's the one utility here, but when we get into it, I'll describe why I don't like them much. And we got TL74, 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 so that's, and a TL72, so that's 4 op amps. This is a dual op amp. I think these are quad op amps, as I recall. Then we've got a couple of capacitors, 4 diodes, and that's it. So the electronic components are pretty straightforward, which again, it's a multi. It's not supposed to do much. The ideal multi just takes the input signal and duplicates it without adding noise, without adding lag, and having very good fidelity to the curve shape, time matched. So we'll see how that works out. But that doesn't take a lot of parts, is what I'm meaning. Now again, Synthrotek does a very similar thing, actually identical thing, to what Division 6 does, which I really, really like. All the components are presented to you in place. captured in a piece of painter's tape, not in plastic bags. This is so much better. So we've got all the resistors, the 4 diodes, 2 104s, that's 0.01 microfarad, and 2 10 microfarad caps. So that's pretty straightforward, and some hardware, including the spacers. Big pin header, power connector shrouded, which is always nice. Power cable. Mucho jacks, so there should be, if I can do my basic arithmetic right, there should be 20 jacks. If I did my, yeah, there should be 20 there. Why are there not 20 jacks? Why did I do the math wrong? 1, 2, 3, 4, 5, 10. Oh, these two only have 3 outs. The top ones have 4 outs. I didn't notice that. The bottom ones only have 3 outs. Now I'm going to speed up the cameras a little bit here because I'm going to take all the panel nuts off these jacks right now while I'm thinking about it. Actually, I'm going to stop the cameras while I'll do that after we go through all the parts. That is almost all the parts. And in here, we have our sockets and our op amps. And these look like genuine TI parts, which is nice. And that's it. Again, the multiple shouldn't be very complex because you're not trying to add anything to the signal. You're just trying to faithfully reproduce the signal. So I'm going to get the soldering iron heated up, and I'm going to take all these panel nuts off the jack. Oh, and I forgot to mention in the intro, like many of the, some of the good multis, if you have one plugged in here and nothing else plugged in, this will be echoed through all outputs and so on. It cascades. So if you have this one plugged in, then this is isolated, but these cascade. And if you have this one plugged in, then these two are isolated, but these two cascade, and so on. In fact, you can see they have little arrows on the front panel to help describe that, which is nice. So we are going to do the diodes first. Since all the resistors are stand-up resistors, we're actually going to have resistor time last instead of first, since they will be effectively the tallest things on the board, so we want to do those last. So we will... Oh, let's look at the boards a little bit. The board's good, all through hole plated. The traces are easy to read too, so if you want to follow along on the circuit, you can easily do so. And the 4 diodes are here, of course, right near the power connector, which makes sense. And they're all oriented the same way, which makes it much nicer. And it looks like we got to leave a little bit of shoulder around the leads, so it goes in like that. Yeah, we're going to do all the other components before we start doing the resistors, since they're all stand up, so we don't want to be knocking them about while we're doing other things. just put these, solder these in, get my soldering iron cable detangled from my meter leads. Now we'll put the caps on. Again, two 104s to provide a little smoothing, buffering, whatever you want to call it. And we'll do the two electrolytics. Polarity matters, and it's well marked on the board. Huh. These circuit breaker holes are a little tight for the caps. That's unusual. Not good or bad, just unusual. These electrolytic solder pads are a little close together, so I'm just going to make sure I didn't bridge it all. Making sure also not to accidentally cut traces on boards. I've had that happen in the past. I've done it in the past. Okay, now the pin headers are here, which is another reason why I want to do the resistors last, because it'd be hard to get at those connectors right there. So I'm gonna do those first right now, and before I even do the IC sockets. Now be careful here. Actually, I'll do it before the IC sockets, because again, this pin header pin is going to be real close. Let's get the socket out. That's an 04. See, if I have this socket on there, it's a little close for soldering. Not bad, but I'll just make it easier on myself. I actually should have done this before I put these two caps on. That's interesting. Because I'm going to have to go between the two caps to solder that one pin. I would have been wise to notice that earlier. So, doing the pin headers as typical, just going to solder one pin, let it cool off a little bit, and I was going to say, and then it's all crooked and you got to straighten it out, but it did not end up being crooked at all. That's unusual. Now we'll get the other end so it's not flopping around. And we'll double check our alignment. Alignment looks good. Oh, look at that. One pin is up a little bit. You may be able to see that this pin is a little bit up out of the plastic. So I'm just going to press it down. Doesn't matter much, but I want it to be the same level as the others. Again, it doesn't really matter. I'm just being a little compulsive about that. And now we'll get the other pin header. Put it here. And that one is crooked. You can see that. That's pretty crooked. So, push on it with our finger, heat up the one pin we did, straighten it out, let it cool, burn your finger, and there, it all looks good now. Now I'm going to put this on the other side of the block so I can hold it steady. And I'll do all these pins. I'm going to do the pins between these two caps first. Again, I should have noticed that before I started, but I didn't. And now we'll put the sockets on. Get them all out. Double check the legs as I'm getting them out to make sure they're not bent. And make sure none of them have gotten pushed out of place, because that happens. Make sure we got the notch by the right side, even though it's my habit to look at the actual silk screening on the board, not the notch on the socket, since there have been a number of times over the decades when I put sockets in the wrong way. The silk screening tells the truth, the socket lies. It's a little up, so I'm going to heat that leg up again and then push really hard, and it's all seated well. It's a little up too. Oh, good. Okay, I'll put the cameras in fast playback as I solder all these pins. Let me get those caps down in that little hole. Alright, that's all the sockets. And again, I am looking at the build guide. I'm actually doing it slightly differently. Again, I put the pin headers on before the sockets because I just felt that was a better way to do it. Now we're going to do all the resistors, and we've got 400K and too many to count 1K. So I'm going to do the 400K first so that then I know any resistor position left over is a 1K. And I'm going to check the resistance on these because they're not real high tolerance, they're brown tolerance bands. And they're coming in, oh no, that's 100, that's dead on accurate. Let me try another one. There, I didn't actually see the meter. Yep, 100.1, that's not bad at all. So let's see where they go. R2. So the base, the ceramic body goes into the circled point. The bent over top lead goes in the uncircled point, but there's a little line connecting them, so you know exactly what you're doing. So that's R2. And we'll do R4. Now, and I'll show you right here why I don't like stand-up resistors. Again, I know they couldn't have made this board this thin had they not used stand-up resistors, but the problem for me is these are going to be on the back. So, get the power header. See, the power connector is going to be here, so this is on the back. So if you're reaching around your rack to change position, change the power connector, or you're setting this down on a table or whatever, these stand-up resistors, if you're not careful, they can, or if you're, I'm sorry, you don't have to be careful. If you're rough, you can, in some cases, bridge them together. It rarely happens. In fact, I would say I've never actually had it happen, but it's something I worry about. So I prefer not to have stand-up resistors on boards, but I'm not going to go on and on about it because I always go on and on about it. So we go into R12. So that's resistor time for the evening. You can see all the pretty little stand-up resistors all in a row. Last thing we'll do on this board is put the power connector on. And that's it. That is the control board components soldered on. Now I'm going to put the ICs on. Okay, all the ICs are in, and the electronics board is done. The only thing we have left to do is put all those jacks on the jack board, and we're not going to do that tonight because it's getting late and cats want to get fed. So we'll finish this up tomorrow. Now it's time to do the control board, or in this case, the jack board, because that's all it is. And we're going to put the pin headers on this side first, because once we put the jacks in there, it would be dang near impossible to get that, get at those pin header contacts. That should have gone on straight, and it did. To the other little guy. And now 18 jacks. So what I'm going to be doing is I'm going to put a jack on. And solder its ground pin. And then I'm going to put a jack on all the way down here at the other end of the board. And solder its jack pin. Make sure they're both flat. Now I'm going to put the rest of the jacks on, and we'll speed through this in playback. Now I'm going to take the front panel and put it on, adjusting the little jacks. There we go. Now the two that I soldered the pin on, I'm going to take a panel nut and put that down about finger tight, not too tight. On that end, and then I got to remember which one they did on this end, and do the same thing. So that sets the height and gets all the other jacks in place so they're not going to move around. Now I'll solder all these pins, and again we'll replay that in fast motion. There's all the jack pins. Double checking to make sure I got them all in, and you might notice here, and here I put two pins together because they're the ground pins, so it doesn't matter. That looks good. Now I'm going to spin all the panel nuts on, and I'm actually going to turn the cameras off for this because that's really boring. Now we're going to mate the boards. I put the power connector in. We're going to mate the boards. One thing you might notice is I'm not using the spacers because I don't care. Since I don't move anything in my studio, I occasionally will leave out retaining stuff because I may want to get in here later anyway. And the pin headers will hold it on just fine. So here we are. Here's the front, side, back, other side, top, and bottom. Now we'll put it in the rack and see how it works. Alright, so it's in the rack and we've got it powered on and no smoke, everything worked. So let's go over to the scope, and on the scope the yellow line is the original signal, the magenta line is the signal from the multi, and remember we're going to be looking for fidelity of signal, no extraneous noise, and no or minimal time shifting. And as you can see right now, the magenta line is not showing any hysteresis, not showing any stray voltage, which is good. So I'm going to turn on the Division 6 sequencer, which is feeding into the number 1, and out right below it is the multi. So there we go. Let's take a good close look at this. The lines seem to be matching up. There we go. So that's at the very end, and it looks like the signal, let me adjust this. Okay, voltage seems to be just fine, and I don't see any time offset, and the fidelity seems to, again, I'm not seeing extraneous noise. So let me try something else. I'm gonna plug the input signal over here, and yeah, it's rippling through there and through there, so that's all good. And of course up at the top there's nothing going on there, except now I'll switch this over to my ADSR, put the ADSR in number 1, and we'll switch that squid to that. Okay, now we'll trigger the ADSR. That looks pretty good. We'll have the sequencer trigger the ADSR now for a minute. See how that looks. Okay, change the attack. I'm seeing very good fidelity, very good spacing. I'm going to speed up the sequencer a little bit. Reacquiring. It's all looking good. Let me extend that. No, that's too high. I took the attack way high. Let me go all the way to the end on the multi. Still looking good. Okay. So it seems to do exactly what we hoped it would do. Try it with my MIDI keyboard. So, looks like a great multi. By the way, I'm going to do something else right here. I'm going to put another, I'm going to take another output from the multi, the output right above where I was, and feed that back into this VCA over here, just to have the loads going in 2 directions. I know that didn't have any effect, which is good. Good. So, looks like a good multi. Again, no distortion, no time shifting, and fidelity to the original wave. And that's all and more that you could ask for from one of these. So that's the 07 multi from Synthrotek. I think I'm going to find it to be very useful in the studio. Thanks for watching the video.